This is lesson 4, chapter 9, and we're going to talk about changing dimensions. The first thing I'm going to talk about is how it has an effect on perimeter. As you look at this example, you can see that we have figure A here, and if we're talking about perimeter, which remember is just the rim, it's 3 plus 3 plus 2, so that perimeter is 8. But if it's twice as big, if every side is doubled, then it's 6 and 6 and 4, and that would be 12 plus 4 is 16. So, to go from here to here is times 2, okay? 2 times as big, you just times it by 2. So, let's look at some examples here. Suppose the side length of a parallelogram at the right are tripled. What would be the effect on your perimeter? So 3 by 4, and then we know this is 3 and this is 4. If it is tripled, then this 3 here is going to go down to be 9, and then that is 9, and the 4 is going to be 12 and 12. So let's see what happens to the perimeter. My guess is that if it's tripled, it's going to be times 3. So the original perimeter, 2 times 4 is 8, and 2 times 3 is 6, so that is 14. Now, 14, if we do this one here, it's going to be 42, and 14 times 3 is 42. So it's 3 times as big. The perimeter is 3 times the original figure. So if it's 3 times as big, you just times it by 3. Okay? Let's see if we understand here. Suppose the side lengths of the trapezoid on the right are multiplied by 1/2. So it's just 1/2 of what it is. So I think the perimeter, the new perimeter, is going to be half of what this is. Let's figure it out. 13 plus 14 plus 24 plus 14. And that would be 12, 13, 14, 15, 1, 2, 3, 4, 5, 6. 65. So that is 65. Now, if it is half of what it is, so we're going to go times it by 1/2, which is just cutting everything in half. So that's 7, 12, and this is 6.5. So now we add it together. 7 and 7 is 14, plus 12 plus 6.5, 0.5, 6, 4, 10, that's 12, 32.5. And because it's 1/2, I would say 65 cut in half equals 32.5. Okay? So whatever you do, if you cut it in half, the perimeter is half of what it is originally. If you do it 3 times as much, it's times 3. If you do it times 1.5, then it's going to be times 1.5. All right. Now, the area is different. Changing the sides will make a bigger difference on the area, the inside. Okay, and let's see how that works. Here we have a figure A, which is 5 times 4. If we want to get the area, it's 5 times 4. So the area of figure 1 is 20. Okay. Now, what if we double? We want to double the perimeter. So now the sides are 8 and 10. 8 times 10 is 80. So it's twice as big perimeter, but it's a lot bigger in terms of area. So it's exponentially bigger. It's 2 squared bigger, or times 4. 20 times 4 gives me 80. Okay, so let's look at an example here. The length of the sides of the triangle at the right are multiplied by 5. So we have a little one here, and they're multiplied by 5. What effect would this have on the area? So 1 times 5 gives me 5, and 2 times 5 is 10. Now let's look at the area here. The area of this one is base times height cut in half. So it's 2 times 1 divided by 2 equals 1. Now, let's see what this is. 5 times 10 divided by 2. That's 50 divided by 2. That equals 25. So it is 25 times bigger. Multiplied by 5, it's not just 5 times, it's 5 squared bigger. Okay? So whatever you're going, if you want to make it 3 times bigger, the area is going to be 3 squared bigger, which would be times 9. If you want to make it 8 times bigger, then it's going to be 8 squared, which is going to be 64 times 64. Okay, well, let's keep going here. Let's do B here. A rectangle measures 2 feet by 4 feet. So, rectangle 4, 2. Suppose the side lengths are multiplied by 2.5. What would have the effect on the area? So we're going to multiply it by 2.5. My guess that it's not going to be just times 2.5. It's going to be times 2.5 squared. And what is 2.5 squared? 2.5 squared is 2.5 times 2.5. Let's see what that is. It is 6.25. So when the lengths are multiplied by 2.5, I think the area is going to be multiplied by 6.25. Let's see if that works. So the area in this one is base times height divided by 2. 4 times 2 divided by 2. That's 8 divided by 2 equals 4. Okay? Now, 4 times 6.25 equals 25. I'm just going to set this to the side over here. I think the new shape is going to be 25 for an area. All right, let's do this. It says the lengths need to be multiplied by 2.5. So 2 times 2.5 equals 5. 4 times 2.5 equals 10. Okay, now let's find the area. Oh, you know what? I made a mistake. I was thinking about a triangle. It's still going to work. This will be fine, but I made a mistake. This is 4 times 2. The area is base times length, not cut in half, so that's 8. So I'm thinking the area is not going to be 25. I think the area is going to be 8 times 6.25 equals 50. Okay, so now when I do 2 times 2.5 and 4 times 2.5, I get 5 and 10. Base times length equals 50. So I was right. Okay. All right, a little confusing, kind of a mess. Let's keep going. Another example here. So a stop sign is in the shape of a regular octagon. Sign A, shown at the right, has an area of 309. Okay, so A, area of 309 inches squared. What is the area of sign B? So we need to find the area of this one. Now we know something from 8 to 12. That's where we're going. So what I'm going to do is I am going to do 12 divided by 8 is 1.5. So 8 times 1.5 equals 12. This one here, B, equals 1.5 times larger. Okay? So, because we're talking about area, whatever area of A is going to be times 1.5 squared. Okay? So let's see, 1.5 times 1.5 equals 2.25. So it's the area, 309, times 1.5 squared, or 309 times 2.4. My new area, based on going from 8 inches to 12 inches, is now going to be 695.25. Let me do some guided practice. Hopefully you're starting to think about this and kind of understand it. It's a little tricky. Okay. Perimeter is so much more straightforward. Area is a little bit different. Okay, each side, refer to the figure on the right, so this one right here, for number 1 and number 2. Each side length is doubled. So if it's doubled, what's the change in the perimeter? Okay, I'm going to find the perimeter here. 4 plus 5 plus 6.5, which is 15.4. 15.4. That's the original perimeter. P equals 15.5. But if everything's doubled, which is times 2, I'm just going to times it by 2. Now my new perimeter is 30.8. Okay? And if I would do 4 doubled, 5 doubled, 6.4 doubled, add them all up, I'm going to get this 30.8. Now, each side of the length is tripled. Describe the change in the area. So let me figure out the area. Base times height divided by 2. 4 times 5 divided by 2. So it's 20 divided by 2, which is 10. So the original area is 10, but I want everything tripled. Now if I just triple this, 5 and 4, so now it's going to be 12 times 15 divided by 2. 12 times 15 equals 180, divided by 2 equals 90. So my new area, equals 90. Now, how did I go from 10 to 90? It says tripled, but tripled would be 30. When you're talking about area, tripled would be 3 squared. Now 3 squared is 10 times 9 equals 90. So it's 9 times. So each side length is tripled, which means the area is 9 times as much. So it's whatever you're doing to it squared. Okay. Let's do number 3. Different sizes of regular hexagons are used in a quilt. Each small hexagon has a side length of 4 inches and an area of 41.6. Each large hexagon has a side of 8 inches. What is the area of the large hexagon? So, to go from 4 inches to 8 inches is times 2. But with area, it's times 2 squared, which 2 times which 2 squared is 4 times as much. Okay, so all I got to do is take my area, 41.6 times 4, and I'll get my new area. And 41 times 6 is 166.4 inches squared. All right. Perimeter, if it's doubled, it's just times 2. If it's area doubled, it's times 2 squared. Okay. If it's the perimeter's tripled, it's times 3. If it's area tripled, it's times 3 squared. All right. If you have any questions, let's talk it out. Let's figure this out and keep working at it.